EX103. You still work with this perfection of ring we introduced. So this is what we call R parenthesis. So this will be seen in factorial. Actually, this gives you a functor. So let's recall a remark. Firstly, if A is a topological ring, then R of A is endowed topology of the inverse limit inverse limit. What is this? This is the weakest topology. Oh, coarse, the most coarse. So it doesn't make sense to ask for. So sometimes it's also called smallest. It doesn't make sense to ask what is the largest or the finest. The finest topology is the discrete topology. Okay, the weakest topology makes this projection continuous for all n. Right, this is the projection. Recall what is this? This is R of A, or a quotient P. There is projection anyway. So then you map it to A. You have tuple of elements. You project it onto the nth item. And this topology of the inverse limit, the smallest one to the weakest topology to make this sedan continuous. Second remark. So in general, if you have inverse limit, let's say AI, right, with the projection onto the i's coordinate denoted by projection I, then the inverse image of OI opens of AI form a basis for the inverse limit topology. Okay, this is actually a topology argument. So let's see, a sketching proof. So what is this projection of OI? This is exactly, I would say, the intersection of this with a one product, a two, except here we have OI, and then plus 1 product. I mean, which is, this is the only open, and all others are the whole space. Other factors are whole space, AJ. And then if you take, by taking intersections of those, right? For example, this PJ inverse OJ, then you got the induced topology from the product topology, right? You have OI, and then all the others are the same, and then in some term you have OJ. And this is very bad notation, but you understand what I'm saying, because the opens of the product topology is given by all but finitely many positions are not the whole space. Instead, they could take some opens of that corresponding space, right? I mean, this is exactly, on the right hand side, this gives you exactly the opens for the product topology. And by taking intersection, you got the opens for the induced topology, which means the inverse limit topology. We didn't prove that, but as common sense, we know that it's the same as the induced topology from the product topology. Why do we want to talk about this? Because second exercise, because we want to prove this, so this serves to prove a more bigger exercise. So still under the theta n, we have introduced prove that. So the elements are let's see, R of OC, which means there is bijection with this is also the same as completion. So we will see this actually. Okay, I will put this as a sub exercise. Okay. Anyway, so this is our let's denote by this by R, and then prove that. So among all the elements, those has its valuation bigger or equal than p to the power n, exactly the kernel of theta n. So the reason we compare this is, so just based on this, you develop a little, it work more than this, work more, a little more, then you could kind of prove the two topologies give the same topology on R, as you could imagine. On the one side we have, comes from here, the corresponds to inverse limit topology. One, this corresponds to valuation topology. We haven't really defined what is valuation on C. On R, sorry, so valuation on R is defined to be, and we also denote it by just wave X if there is no confusion, defined to be this valuation of C. So X is element of R in particular. If you write it this way, then all the elements is in C, OC, sorry. And so it has valuation. I'm going to define the valuation for R is defined to be the valuation on X0 using the valuation on OC. Okay, let's prove this. So this is quite direct, actually. So let's say X is in kernel theta n, if and only if. So if and only if what? X n is in P O C. Sorry, if and only if it's not X n is in P O C. Let me think. If and only if X n. I mean, each element could be written into different way. We have recalled this last time, right? Writing it this way as element of this. Writing that way, upper index as element of characteristic 0. So here, the same as xn equals 0. C quotient POC. The same as saying xn is in POC, right? The same as saying that valuation, because we have normalized valuation. Let's say here, normalize valuation of valuation on C, P equals 1. So C. And without loss of gen, when there is no confusion, we just write way. And so way of xn is bigger or equal than 1. And then this is equivalent to say way of xn to the power p to the power n bigger or equal than p to the power n is equivalent to way of x0 bigger or equal than p to the power n. This is equivalent to say way of x bigger or equal than p to the power n. This is exactly the left hand side. Okay. Remark. I think this maybe should explain a little more. So I put also sub exercise. This implies that the topology defined by valuation is nothing but the inverse limit topology. And therefore it's complete, because the inverse limit topology is complete. Just think it for a while. So, as we remark, what should be the open for the inverse limit topology? The opens, the basis. So basis, this is the idea. What is in my mind? So basis for inverse limit topology should be should be theta inverse of O n. When I write O n, I mean opens of, I would rather write OC, OCP, or OCK, OC. And so this should be, or of course you could write this, but it depends on how you map it, right? Yeah, let me just modify my theta to be the map from R A to, sorry, from R O C to O C, X N map to X N, and then the inverse limit topology should have its basis. Consider what are the opens of OC. Opens of OC should be those comes from the valuation, right? So the valuation let me just describe the opens of 0. So the opens of 0 should be those. So those balls centered 0 and with those elements with valuation R, right? Those, X in OC, valuation is bigger equal, because you think of P squared bigger equal than R. Some R, we will take some rational number. Right. So let me just fix one R. Then this should correspond to those X and R such that valuation of X n is bigger or equal than R, and then this corresponds to X R valuation of X n to the power P to the power n is bigger or equal than P to the power n times R. This corresponds to X such that valuation of X naught is bigger or equal than P to the power n times R. This is equivalent to those x in R whose valuation is bigger or equal than p to the power n minus R. You see that I'm trying to convince you that actually the opens of this inverse limit topology corresponds to the opens for the valuation topology, right? Very nice. So this is already the second exercise. So exercise 3. Let me first put a remark. So the most important case in practice for R of A is that A equals OL hat with L. With L being a subfield of K var containing K0. And its completion L hat by the p-adic valuation. Identify OL quotient POL by OL hat quotient by P OL hat. Then so I put this as exercise, sub exercise. Then ROL hat is the same as quotient by POL, also the same as OL hat quotient by POL. Okay, so sketch and proof the sub exercise. So the idea is that it suffices to prove that for any Cauchy sequence of OL it stabilizes modulo P. Right, in particular this means that then the limit is you have a representative still in OL. And so there is bijection. Because the right hand side could be think of as Cauchy sequence. And if the Cauchy sequence already stationarized, then the limit is just that limit, which it's stabilized, which means it stabilized a finite step, then it's still in OL. I mean, stabilized means because sequence is elements of OL, such that whose limit may not be OL, depends on whether it's complete or not. But after you quotient P, and if you can show that your sequence stabilized modulo P, then it's okay. So proof. Taxing OL hat, but not in POL hat. And let xn be a Cauchy sequence. Now, such that converging to X, we know that for any epsilon there exists an epsilon big enough integer such that starting from index bigger than this integer, elements be closer enough, and so the valuation of their difference become bigger enough. Now let this epsilon denote, let this epsilon denote p-adic valuation of P, then this p-adic valuation bigger than epsilon become bigger than the p-adic valuation of P for any n bigger or equal than epsilon. Or just say bigger or equal than n for some n bigger or equal than 0, big enough. Notice that we also have p-adic of X less than the p-adic of P, and the p-adic valuation of X n is also less than the p-adic valuation of P for any n. I would say for n big enough, because so what I'm seeing is that p divided x minus x, well, that then divides x, this is by assumption, and p doesn't divide xn when x, because xn is closing to x when it's big enough, and this would be the true case, and this should imply that x is covering to xn starting from some big enough index, and all those xn already in OL. This is just saying that when we're talking about Cauchy sequence, elements become closer and closer, so because this is a p-adic valuation, become closer and closer, so their valuation will be bigger and bigger, and then modulo p then it becomes stationary, right? There's nothing special there.